Hello!
Welcome back from intermission. My name is Sinclaire Manning, aka Major Merger.
And I am Dr. Brian Mulligan, also known as AstroBit.
And we are here to present you this month's top news stories in astronomy. First up, on November 5th, NASA's Parker Solar Probe flew within 15 million miles of the Sun, which sounds far, but it's far closer than any previous mission has gotten to the Sun. So on Wednesday, November 7th, 2 days later, the probe phoned home, letting its controllers know that it's functioning properly.
Parker probe phoned home.
Parker probe. And it is continuing to collect data, which is awesome. So the probe also set the record for fastest moving spacecraft during its first solar encounter, maxing out at a top speed of 213,000 miles per hour, which is, gotta love that no friction in space thing to zip you forward.
No police in space either.
Yeah, no police in space, yeah. Anyway. However, the Parker Solar Probe will be breaking both of these new records several more times over the next 7 years, as it makes 23 more flybys of the Sun, getting closer and closer with each pass. And the final close approach, set to occur in late 2025, will bring the spacecraft within 3.83 million miles of the Sun. And during that dramatic flyby, the Sun's gravity will accelerate it to around 430,000 miles per hour. The Parker Solar Probe was a $1.5 billion endeavor launched on August 12th and set out to help scientists better understand the Sun's structure, composition, and activity. So mission team members have identified 2 questions in particular that they would like the probe to answer, including why is the Sun's outer atmosphere, or corona, so much hotter than the surface, and how solar winds get accelerated to such high speeds. So the Parker Solar Probe is expected to unveil many secrets of the Sun, so stay tuned for more updates and more record-breaking achievements.
All right, also in terms of satellites in space, I've got good news and bad news. Hubble Space Telescope is back up and running in normal operations mode, but the bad news, Kepler Space Observatory, the Kepler mission has now officially ended.
Oh.
So Hubble experienced a gyroscope failure back in September. A backup gyroscope was turned on, but was returning strange readings. So Hubble was temporarily placed into a protective mode while those were diagnosed. After being commanded to do several rotations maneuvers, something was probably lodged into a sensor on that gyroscope or something. It came loose. It's now working normally, and so Hubble is now back online and performing its normal science operations. Unfortunately, Hubble is down to 3 operating gyroscopes. The other 3 are all disabled at this point. So Hubble requires all 3 to work properly. So the next failure is going to mean that Hubble is going to be reduced in its capability, but it can operate on a minimum of 1 gyroscope, so it's going to be able to keep operating for at least a few more years. So we're still doing okay. On the other hand, the Kepler Space Telescope was formally decommissioned on November 15th after running out of fuel. The satellite had been in protective mode in early October as it was having difficulty maintaining its orientation. After further review, it was determined that Kepler no longer has enough fuel to continue working normally, so it was given commands to shut down all of its equipment and disable all the fail-safe modes that would cause it to try to point back to Earth and make contact. So during the nearly 10 years that Kepler was in operation, it observed over 500,000 stars, has found over 2,500 planets with thousands more awaiting confirmation, and has observed 61 supernovae. The successor to Kepler, fortunately, is already up. The Transiting Exoplanet Survey Satellite, or TESS, it began its normal science operation just this past July. So expect a lot more planet discoveries in the near future.
And I think all our exoplanet colleagues would agree that Kepler has totally changed the game for astronomers, and we owe a lot to it. So thanks, Kepler. All right, next up. For the first time, astronomers have observed the final stages of galactic mergers, peering through thick layers of gas and dust to see pairs of supermassive black holes drawing closer together, as well as the black hole's rapid growth. So it's believed that supermassive black holes reside in the centers of all galaxies, and previous work has found that mergers of galaxies might help fuel their growth through accretion of additional gas and dust, but also that the black holes at the cores of two colliding galaxies may combine to form one larger black hole. So now astronomers have observed several pairs of galaxies in the late stages of merging and have seen the black holes drawing closer and closer via their high-energy X-ray emission generated from the black holes that can be visible even through all this gas and dust. So in all, Michael Koss and collaborators examined 481 galaxies and found that more than 17% host a pair of black holes at their centers, which is a clear signature of a late-stage merger. So in the image here, we have several pairs of galaxies, and you can see the zoom-in, which is like the more reddish image, is the X-ray image, showing where the black holes are residing within these mergers. So with these findings, there's now a bit more support for the theory that galactic mergers may be a key way or a key mechanism for growing black holes.
Pretty cool. All right, back within our own solar system, the extraterrestrial asteroid Oumuamua is back in the news this month. A paper was submitted, Oumuamua, for Christina, Oumuamua. So a paper was submitted that suggested could be an extraterrestrial probe. So starting with research published earlier this year that found that Oumuamua had experienced an acceleration when it was within our solar system, a very significant, small but very significant change in its velocity. In their research, and not this group's research, but the previous research, they find that light from the sun can't be responsible for for explaining this acceleration unless the asteroid were extremely low density or hollow. So Shmuel, I apologize, I'm sure I'm pronouncing his name wrong, Shmuel Bilay and Avi Loeb of Harvard submitted a paper this month suggesting that this paper garnered a lot of headlines in mainstream media, as I'm sure you know. They suggested that an object could have such low density if it were a solar sail or probe from an alien civilization. Now, while this possibility can't be ruled out, there's no way to test this hypothesis, as Oumuamua is already outside of our solar system, and there's no way for us to practically reach it with our current technology. It is important to note also that Oumuamua is the first object within our solar system that we are absolutely certain that it came from outside the solar system. The probability that the first such object that we see is in fact an alien probe is extremely, extremely low probability. However, they suggest that its mere presence is already improbable, and so therefore it's more likely to have been targeted to come to our solar system in the first place. Partly based on theoretical estimates of the number of objects that are out there in space that are about the same size, I don't think this argument is going to pass muster within the astronomical community. However, there's speculative research does find that alien probes could successfully make a trip to the solar system, so there is some useful information out of their research, and they also call for more detailed observations should another similar object ever be discovered within our solar system.
It's always aliens.
Always aliens.
All right. So it was announced this month that the nearest single star to the sun looks to be the host of a large icy planet. So astronomers have found strong evidence that Barnard's star, a dim red dwarf star residing a mere 6 light years from us, has a planet roughly 3.2 times the size of the Earth orbiting it. So the newly detected world, conveniently named Barnard's star B, remains a planet candidate for now, but Ignacy Ribas, a researcher at the Institute of Space Sciences in Spain, says he and his colleagues are 99% confident that it will be confirmed as a planet. Barnard's star is about twice as old as our sun, so about 8 million years old, 1/6 as massive, but just 3% as luminous. So because it's so dim, its habitable zone lies extremely close in, about 0.06 to 0.1 astronomical units from the star. So we're 1 AU astronomical unit from the sun, which is 93 million miles away. So 10%, 9.3, less than 9.3 million miles away from Barnard's star is this planet. So Rivas and the team used observations from 7 different instruments spanning 20 years of measurements to make a precise radial velocity measurement, which astronomers look for changes in starlight due to the gravitational tug of an orbiting planet. So Barnard's star B, which, as I said, lies 0.4 AU, around 0.4 AU from its host star, completes one orbit every 233 Earth days. The orbital distance is similar to that of Mercury, but due to the dimness of Barnard's star, the planet lies in the system's snow line, so the region where volatile materials like water can condense. And so it's believed that this planet is actually covered in ice with an estimated surface temperature of minus 275 degrees Fahrenheit. So previously, only giant planets had been detected at such distances from their host stars. So the discovery of a lower mass planet, and we call this a super-Earth, at the snow line places very strong constraints on formation models for this type of planet. And future observations from Gaia spacecraft will ultimately help to confirm the planet, as well as the next generation of large ground-based telescopes could directly image the planet as well.
Cool. We're going to name it Hoth, right?
Yeah.
All right. So finally, astronomy not in the news. This is a segment where we talk about we highlight a story that's generated a lot of discussion within the astronomical field, but hasn't made it into the mainstream news. So this month's story is about a form of dark energy that can help explain the discrepancy in measuring the expansion of the universe. So multiple studies have been performed. This graph here is like each one of these points is a different study measuring the expansion value of the universe. So methods that rely on measuring the cosmic microwave background, the most distant light that we can see in the universe, or earliest light that we can see in the universe, it finds a value for expansion of about 68 or 69 kilometers per second. Whereas methods that rely on using objects that we can see within the universe, most specifically supernovae, find a value of about 72 kilometers per second. And so you can see that there's kind of a group over here and a group down here, and they seem to completely disagree with one another. The error bars are enough that says, yes, this one is definitely not the same as this one. Vivian Poulin and his collaborators have just suggested a form of dark energy in the early universe that can generate this difference. The dark energy that they suggest starts out extremely strong in the early universe, kind of forcing expansion to go on in the early universe, but then decays and disappears by the time that later effects occur that we can also measure. So they're essentially able to explain both this discrepancy as well as other discrepancies, or not discrepancies, but other aspects of the expansion of the universe that we can measure, such as baryonic acoustic oscillations that I'm not going to go into. So they can explain these various observations. It's not clear if this dark energy is the same as the thing that we call dark energy that's currently causing the expansion or acceleration of the expansion of the universe. Further research is required to see if there are other explanations for both these discrepancies and whether any of this could be related to the current form of dark energy. That was a lot. Hopefully you got a piece of that. All right. Well, that's all we have for this month.
Thank you very much.
Thank you all for coming out. Thank you for coming to our 50th show.
Enjoy our final talk.